Hi everyone, my name is Montserrat and in this lesson video, I together with my classmates Javier, Alan and Aaron will explain you the conic section. So let's start. First, what are conic sections? Conic sections are figures that can be formed by slicing a three-dimensional right circular cone with a plane. There are different ways to do this, and each way yields a different figure. This figure can be represented on the graph as well as algebraically. The four conic sections are circles, ellipses, parabolas, and hyperbolas. Now, I'm going to tell you about the first conic section. The first conic section is a circle. A circle is formed by cutting a circular cone with a plane perpendicular to the symmetry axis of the cone. This intersection is a closed curve, and the intersection is parallel to the plane generating the circle of the cone. A circle is also the set of all points that are equally distant from the center. This is the equation or formula of the circles. X minus h squared plus y minus k squared is equal to r squared. In this case, h and k are the center of the circle and r is the radius. Now, I'm going to explain you how to solve or find the equation with some examples. The first example says to find the equation of a circle with center 5 and 2 and a radius of 5. Remember, this is the formula. H and K is the center and R is the radius. So, I put in the correct order the center and the radius of the circle in the equation, and I have x minus 5 squared plus y minus 2 squared is equal to 5 squared. So, the 5 squared is the radius. I need to do the operation, so I get this equation. X minus 5 squared plus y minus 2 squared equal 25. Well, you can leave it in this way the equation, or you can develop the equation with a binomial rule. So, how to solve the equation above? To solve the equation, you can use the binomial rule. The binomial rule is the square of the first term plus the double product of the first term by the second plus the second square. This is the equation that I'm going to solve, and the next is the result of the equation above. So, the square of the first term in this case is x2, and the double product of the first term by the second is minus 10x, and the second square is 25. I do the same that I did the first term with the y. So I have x2 minus 10x plus 25 plus y2 minus 4y plus 4 equal 25. But the equation has to be equal to 0. So the number 25, I change the other side of the equal in the negative wave. So we order the terms in the correct way, and I add equal terms, and this is the final equation. x2 plus y2 minus 10x minus 4y plus 4 equal 0. The second example say to find the center and the radius of the circle by the equation. This is very easy to do. This is the equation. X minus 3 squared plus y plus 4 squared equal 16. Remember, the center is h and k. 3 is h and 4 is k. But you can change the negative or positive sign. For example, here I have negative 3, so I change to positive 3. And here I have positive 4, so I change to negative 4. Now the radius. The radius in the formula is r squared, so r squared is equal to 16, and then r is equal square root of the 16, so the radius is equal to 4. And for this way, I found the center that is equal 3 and negative 4, and the radius that is equal 4. Finally, the graph. If you know the center and the radius, to do the graph is easy. I will use the Cartesian plane to make the circle. So first, I locate the center. In this case, the center is 5 and 2, so the letter A is the center. Then I count 4 spaces for any direction of the center of the circle. And finally, I do the circle around the center and the radius in the graph. And that's all for the circle.
Hello, my name is Xavier Ibarra, and today I will talk to you about ellipses. Ellipses. An ellipse is formed by cutting a three-dimensional cone with a slanted plane. This is different from a circle in that an ellipse doesn't have a constant radius. It has a radius that changes in between an x radius and y radius. However, an ellipse has two focal points in which the sum of the length of both focal points to any given point on the ellipse is always the same. The standard equation of an ellipse is given as follows: x less h squared divided r squared plus y less k squared divided r squared is the same to 1. Ellipses have many similarities with the other two forms of conic section, parabolas and hyperbolas, both of which are open and unbounded. An angled cross section of a cylinder is also an ellipse. Ellipses are the closed type of conic section, a plane curve tracing the intersection of a cone with a plane. Ellipses are the closed type of conic section, a plane curve tracing the intersection of a cone with a plane. Ellipses have many similarities with the other two forms of conic section, parabolas and hyperbolas, both of which are open and unovaled. An angled cross section of a cylinder is also an slip. An ellipse may also be defined in terms of one focal point and a line outside the ellipse, called the directrix. Where h and k is the center of the ellipse, r and s is the distance from the center of the circle in the x direction, and r and y is the distance from the center in the y direction. For all points on the ellipse, the ratio between the distance to the focus and the distance to the directrix is a constant. Drawing ellipses. Ellipses appear in descriptive geometry as images, parallel or central projection of a circle. The principle of ellipsographs were known to Greek mathematicians such as Archimedes and Proclus. If there isn't ellipsograph available, one can draw an ellipse using an approximation by the four osculating circles and the vertices. However, technical tools ellipsographs to draw an ellipse without a computer exist. There exist various tools to draw an ellipse. Computers provide the fastest and most accurate method for drawing an ellipse. To develop the equation of the ellipse, we will first transform this equation to bring it to the equation of an ellipse. Next, we are going to complete the perfect square trinomial that is within each parenthesis. We are going to complete the expression with a third term. Now, we will parenthetically group terms that contain the same letter. We need x squared and y squared to have coefficient 1. In this case, x already meets that condition, but y squared doesn't meet. We must remove the number 4. For this, we will raise the factor to find the common factor of 4. In the first one, we take out half of 6, which would be 3, then it is squared and there are 9. In the second, half of 4 is 2, it is squared and gives 4. We start by writing the terms that contain the x, then those that contain y, and we are going to pass the independent term to the other side. Now we factor each trinomial to the perfect square. Inside the parentheses are two terms, the square root of x and the square root of 9, and between terms the sign of the second terms. We will repeat this in the second case. On the other side of equality, we must solve the operation we both have 4. And in that way we complete a perfect square trinomial. Remember that on the two sides of the equation we must write the numbers that we add to compensate for the fact and that it is balanced. We already have the center of the ellipse that is going to be in the coordinates c, 3 and 2. Now let's do the same with the denominators. We know it is a horizontal ellipse because the largest denominator is 4, so that number is below the x, and it fits perfectly with this model. Now we are going to determine who is h, k, a squared and b squared. Less h is equal less 3, then h is equal 3. Less k is equal less 2, then k is equal 2. Now the ellipse begins to take shape, but remember that it must always be equal to 1, so we must change that 4 to 1. A squared is equal 4, then a is equal 2. B squared is equal 1, then b is equal 1. We bring together all the elements we have, which are c, 3 and 2. A is equal to b is equal 1. C is equal root of 3. We need to determine how much c is worth. To determine c, we will use this relation. C is square root of a squared less b squared, and we substitute the values. With this, we find that c is equal 1.7. Now we divide each equation by 4. Then we simplify. The first cannot be simplified. We will stay the same. In the second, we remove both 4, and on the other side of equality, we do it, and we have 1. It is a horizontal ellipse. First, we draw the Cartesian plane. We are going to place the values on the x's. Now we locate the center of the ellipse, 3 in x and 2 in y. With this, we can already plot the graph of the ellipse. We highlight the external vertices and name them. Now we will find the coordinates of the vertices, and later the coordinates of both focus. With this, we can already trace the edges of the ellipse. Now, from the center we will count 1.7, which is what C is worth to find the focus. How A equals 2, then we will move 2 units sideways. How B equals 1, then we will move 1 unit up and down.
Parabola. What it is a parabola? The term of parabola comes from the Greek through Latin, whose meaning is the same from Spanish and comparison, in addition to the curve that results from a section of the cone. This word goes to the Latin as a parabola, parabole, with the same concept that it had in the Greek. In mathematics, it is the conic section of equal eccentricity, resulting from the cutting a straight cone with a plane whose angle of inclination with respect to the axis of revolution of the cone is equal to that present via generatrix. The plane will therefore be parallel to this line. It is also defined as the locus of the point of a plane that are equidistant from a line called directrix and a point inside the parabola called focus. In projective geometry, the parabola is defined as the enveloped curve of the line that unit pair of homologous points in a similar or similar projective. The parabola appears in many branches of the applied science because it is a shape corresponding to the graph of a quadratic equation. For example, parabola are the ideal trajectories of body moving under the exclusive influence of gravity. Property of geometric and how is used this. Parabola is the locus of a point that moves in a plane in such a way that it is equidistant from a fixed line, called directrix, and from a fixed point in the plane, which does not belong to the parabola, nor to the directrix, are called focus. A parabola whose vertex is at the origin and its axis coincides with the axis of the ordinates has equation from the g and a axis plus weird parameter a specific the scale of parabola incorrectly described as the shape of the parabola signs as stated from before. All parabolas have the same shape. When the parameters is positive, the parabola opens up, and when it is negative, it's open down. How to know when the parabola are open? When working with the parabola, you must know 3 fundamental things. First, where it's open to be able to graph. Second, know to the vertex of focus. Third, know the value of the letter P. Well, to know where the parabola opens, right, left, up or down, you must observe the equations. First equation are x line h quadratic plus 4p gq. Second one are x line h 2 equals minus 4p. The third one are g line q 2 equals 4p x line h. Therefore, our g line q2 equal minus 4p x line h. The first thing we identify is that it is open the letter that is raised to 1. After 10, the letter that is raised to 1 is the g, and x is the raised to a square, so h will be a number like p and q. Then if g and q is not a square, it is, and that means that it's open parallel to g. It is the bone up and down, so the axis g is drawn up and down. Now, how to know if it's open up or down easily, as in x line h 2 equals 4p g a line q. In the part of p of 4p is positive to the g axis, and the x line h quadratics equal minus 4p gq hat minus 4p. This is negative of the axis g, so these are open to down. Now in g minus q 2 equal 4p x and h is positive, but in the x axis will be to the right, and it negative of the x axis to the left. This will always be something that we must always identify. Can you see that x and g are always accompanied by g and q, but you wonder why? This is because the h and q are the vertex coordinate. First h, what will be x, and the q will be g. That's why the h is always accompanied by the letter x, like x and h, and the letter q always be accompanied by the g and q. So this is gonna be the coordinates of the vertex. Example: x minus 3 for quadratics equals 8, g plus 2. Remember, always see the right side. G plus 2 this are positive. After taking you see the sign or number 8 will be these are positive, so this parabola are open that the positive of g, what it is up. Example. For example, another example is g plus 2 equals minus 4 x plus 5. It is left. The coordinate of g, h and q's always be h be accompanied by the x, and the q with the g. It will be x minus 3, h will always be 3, and the letter q is g plus 2. These are 2. So this can be described like x minus 3h plus 8. G plus 2q is open up. B 3 minus 2. Well, but you stay thinking, what is P? So P is the letter of the middle. In this case is 8. This is P. Well, GQ2 equals minus 4P x minus h 8 equals 4P. So x and h, two quadratics equal 4P GQ. 8 divide 4 equals P equals 2, and will be P are 2 units. So this divide 4P between 4 divide 4 is like a 1. So this can be see the P we are the value of 1, so this is gonna be left.
A hyperbola
is a type of a smooth curve lying in a plane, defined by its trigonometric properties or by equations for which it's the solution set. A hyperbola has two pieces called connected components or branches that are mirror images of each other and resemble two infinite bows. The hyperbola is one of three kinds of conic section, formed by intersection of a plane and double cone. Parts of hyperbola in the Cartesian plane. In the hyperbola, you can see an axis of symmetry, two vertices. The distance between the vertices is the constant difference between the length PF and PG, two asymptotes which are not part of the hyperbola but show where the curve would go if continued indefinitely in each of the four directions. And strictly speaking, there is another axis of symmetry that goes down a hyperbola with a center in zero. You can see two different types of hyperbola. The hyperbola that centers zero in horizontal and the hyperbola it centers zero that is in vertical. A hyperbola with a positive x is horizontal and the hyperbola with horizontal y is vertical of the middle and separates the branch of the hyperbola. To solve a hyperbola found in the form of the general equation, we need to convert the general equation to an ordinary equation of the hyperbola. If you have a hyperbola in the standard equation, you need to start in the step number 2 of this process. We have this equation to convert to a standard form. To begin, we will organize the equation differently, accommodating the terms with a positive sign of the left side. After that, we need to move the number without the variable to the other side of the equation. Now, we are going to group the terms that contain the variable x using parentheses, and the terms that contain the letter y too. In this step, it's necessary to change the sign of the negative term, so that is the function is fulfilled. Now, we are going to take the common factor of each parenthesis, using the letter that it is squared. After this, we are going to perform the completion of the perfect square trinomial inside each parenthesis. To do this, we are going to divide the number accompanied by x divided by 2, and we will square it and place only the number. In the another parenthesis, the process is the same. Now, to balance the equation, we will add the independent terms to the other side of the equal sign, and we will obtain a result like this. The last result is going to be divided by the independent term of the equation. We will simplify the equation step by step. The first step is finished. Now we have the standard equation of a hyperbola. The first step is finished. Now we have the standard equation of a hyperbola. To solve this equation, I am going to use the standard equation of a hyperbola applied in my equation. Based in the formula, I am going to change the things using the laws of things. To find the center of a hyperbola, that its center is not 0, we are going to take the numbers that are in parentheses, but without the variable. In my case, -1 for x-axis and +2 to y-axis. Now, we need to find the corresponding values of a and b. To do that, we are going to get the square root of them to be able to continue with our process. To get the value of c, we're going to use the formula a squared plus b squared, and the result we will extract square root. Remember a little detail. When the equation in the x-axis is positive, the hyperbole is horizontal, and when the y-axis is positive, the direction of the hyperbole in the graph is vertical. To graph the hyperbola, we will use the Cartesian plane. We already have the location of the center of the hyperbola. We are going to place it in the Cartesian plane. Being a horizontal hyperbola, we are going to measure from the center the value of a to the left and the right side, and we will mark it on the Cartesian plane as a reference. Now, with the points A and B, we're going to form a rectangle delimited by A and B, and then draw two opposite diagonals in the rectangle previously drawn. We will place the value of C horizontally on both sides of the hyperbola as a point. We are going to plot the curve at A, beginning to plot across the width of C without touching the point C. If you need to graph any equation electronically, you can use the GeoGebra software. Using this software, we will check if our equation is correct. To finish, we're going to check the eccentricity of the hyperbola. All hyperbola has an eccentricity greater than 1. The formula for eccentricity is C divided by A, and the result is greater than 1. Let's check it. The hyperbola is correct.
Thanks for watching our video about conic section. We hope it has been easy to understand, and that is from us.